All right. Well, hopefully the audio is better. Although, who knows with these things? The video too, man. Don't touch your camera ever. But that doesn't matter because when you use it in different apps, it's gonna look completely different anyway. Apparently, I hate Windows. It's so broken. I've been following more of this Rust nonsense. I think I just call them Rust chards from now on. I mean, if you can't make a technical argument, that's fine. Just shut up. It's a technical question. Right? I was watching Primeagen. I didn't watch the whole hour because he's funny, but I ain't got no hour to be entertained by him. Um, I like how he's a fence sitter, at least in the beginning. That's pretty funny. I think there's a gap, right? Like people are making technical arguments based on language, right? When the technical argument is based on release, engineering, and builds. And I think that a lot of people who haven't worked on large code bases, well, they don't even know what large code bases are anymore. And they don't understand the build process because we have these things that aren't builds and that we call builds, right? And what ends up happening is, you have like, oh, you know what's wrong? The package and dependency system. Okay. Do you know why we never had that problem before ever? Because it was part of a build. And when you do proper builds, you don't have package dependency problems. Those are problems that are way up the stack from a build. When you have a stable build, you don't have the problem of importing modules. Now you can argue, well, they're not really modules because they're precompiled code or whatever nonsense you want to say. But look, the problem doesn't go away, right? It just before it was at a lower level, like when you type make. And so we had things called release engineers, right? We don't have them anymore. What people are doing is importing millions and millions and millions of lines of code they didn't write that they don't know how it works. And they're not even using all of it, right? They're probably not using most of it, but your average program, I've done the measurements. Like you can do the measurement. It's not that hard, right? But you have to think about it and you have to do the measurement, it's the doing part that people fail at reliably as near as I can tell. But I've done the measurement, right, for some projects. It's like, oh, well, they wrote, 6 or 800,000 lines of code and they're importing 7 or 10 million lines of code through libraries. It's like, well, it's a library. It's not really a line of code. Yeah, but it's not your code and you didn't write it. You don't know what it does. And you have to do the integration for that code, right? Because the integration was done by somebody else, usually a release engineer, package maintainer, right? Which is way below release engineer. Like, who cares? Like, package maintenance, irrelevant, right? Just leftover vestiges of the things you should have done in your build but didn't. Now you have to do them at a different layer. Now maybe it makes sense to do that at different layers of abstraction for certain things. Sure, I'm not like, oh, no packages. No. I'm just like Ginger Bill and Odin. Packages are easy, guys. Really, and the number of package managers don't do dependency trees and just like figure that out because that's a solved problem is amazing. I'm like, you guys just don't know this is a solved problem. And that's what we're going through in software engineering. We're solving problems that have already been solved. It's not even reinventing the wheel. It's not knowing that anybody ever would have needed a wheel before, and therefore not even checking to see how many wheels there are out there that definitely fit what you need. Right? Instead, you're trying to re-engineer something because you didn't understand it or you didn't look. It's ridiculous. And then of course you can't because you suck as an engineer. Because a good engineer would know the landscape before he started building, right? Like first you learn what's already been done, then you build. And I think it's deeply disappointing because one of the things that's happened, in my opinion, is that we've reached the end of novel coding. Like all the cool things have been built. I mean, not literally all of them, but pretty much all of them actually have been built. You probably don't know about them. I know about a bunch of them that almost nobody else knows about because they're just hiding in white papers that no one's read. And fair enough. Like there's a there's an infinite add hash algorithm that uses a ring like data structure, and allows you to add it's an infinite size hash algorithm. I've never seen anyone use it, right? But it's immensely useful. Thinking like kernel, huh? Right? There was a big thing. I used to talk about this quite a bit. There was a thing called the LMAX um, presentation. And the LMAX was kind of cool. It was done by a company called Betfair in the UK, I believe. And sports betting is bigger by transactions than the stock market in the US, right? So Betfair, like, it was a big deal. So they write the software, and they basically, they're trying to do, I think it was 10,000 transactions per second, or maybe it was 100,000 transactions per second with sub 1 millisecond latency. Now this is at least 10 years ago, probably 15 years ago, and they did it, by the way, and they were able to run it, just to tell you how old it is, on a quad core Q, are they Q6400s? Right. And they could do some ridiculous, I think it was 100,000 transactions a second at sub 1 millisecond latency on very old hardware, right? Because that's what there was back then. Actually, it was a green version of that chip. So it was the second gen of that chip. That's how old it was. Whenever that chip came out, the Q6400 or 6600, I forget, the original quad cores, the EV version, when that chip came out, this is when they wrote that software. It's that old. And I think the presentations are still out there. You can see it's a masterwork on how to actually do stuff, and how much Java is terrible, and how to fix it. Like, this is the other thing. They wrote it in Java. I was like, well, I mean, the initial thing, I was like, yeah, whatever, assembly language, C, you can do it. They're like, no, we wrote it in Java. I'm like, wait, you did what? Now that's an accomplishment. It's sort of like Plenty of Fish, right? Marcus Friend goes and writes this, this dating app thing, right? Or it wasn't an app back then. He writes this dating website, and he's like, oh, the whole reason why I wrote it was because I wanted to learn how to build, I forget what it is, in ASP. And he used no libraries on purpose. And he was able to make it work on Windows with IIS. And I was like, you can't do that with IIS. IIS is too slow. No, you can in ASP, because ASP is not a terrible language or anything. It never was, but you have to write everything yourself. Like, you can't rely on libraries. Oh, right. And he did. And that thing was making him 10 million bucks a year for years. So good for him. He's a good coder, right? Like, obviously. If you haven't done that, you're probably not. It's not that hard, right? This isn't hard. And I think a lot of this boils down to people don't understand scale. The way you do algorithms when you're writing an app is different from when you're writing an application for the same function, which is different from when you're writing something that scales up, to millions of users or something. The number of users and the type of users and the scale changes how you do the same thing, because that's how scale works, right? If you're going to cut down a tree in your yard, you can use an axe. If you're going to cut down 10 trees in your yard in the same day, you're not using an axe. The implementation changes. It changes from axe to chainsaw. It's true in compute. And if you don't know what a build is, because you've never done C or assembly or something with a multi-stage build process, then you probably don't understand what's going on. And that may, like, hey, that's okay, man. Like, just code Python for the rest of your life. It's fine. Like, Python's great. I'm using Python now. I use Python all the time. Python's the reason I didn't write my own programming language, because it had just come out. And I was like, somebody introduced me to it, and I was like, oh, here's the one feature I care the most about, which is indentation as braces, basically. I'm like, well, that solves the scoping problem I needed to solve, where like I said, I mean, if you went through the Linux kernel in the early days and you just formatted it correctly, you find bugs without reading the code. So that's the big reason why I like Python. Now, Python's got lots of limitations, and boy, it can be slow. But also you can get around that by writing them in C and just stubbing them in, because it stubs into C perfectly. That's one solution. If you can't stub into C perfectly, maybe you're the problem. Yeah, maybe. But if you don't understand builds, and I was talking to Ginger Bill earlier today, just a few mere minutes ago, in fact, I was like, somebody should go through and analyze C object files and optimize based on that, and then rewrite the C code, because you could do that. Like, this is, I mean, it's a big project. I'm not saying it's trivial, but like, wow, you can improve C that way and have memory safety. Now, you put memory safety in C, you just wouldn't put it in the language. You'd put it in the compile stages and have it fix the language back upstream, which I don't think anyone's done. Maybe Cscope does some of that. I don't remember. It's been too long since I've done large scale C projects. I should write my own apps in C, which is hard enough. It takes forever, for sure. I think a lot of things people are complaining about, at least, from what I was seeing on the Primeagen stream, was the law of humans. These Rust guys are part of a cult, and they don't know what a cult is, so they don't see it. And like, fair enough, like, fine, we all have our blind spots. Like, they're complaining about things that are human problems. Like, oh, I'm quitting this thing. Basically, Hector quit because he burned out. Like, it's 100% clear. Okay, he quit because he burned out. Now, he's blaming the difficulty of Rust and nonsense. He had burnt out on his previous project. People burn out. We're not machines. Like, that's why we have computers. Like, we wouldn't need computers if we were entities with the same properties. So, like, fair enough. But don't blame the Linux maintainers because you burnt out. Like, that's silly. Like, what are we doing? I think that's part of the problem, is that, people are missing that fact. And there's other laws of humans, right? Like, a lot of people were talking about brigading. Well, it was the Rustards that were doing the brigading. I didn't see anybody else doing brigading. And how would you tell brigading from opinion shared by most people or democratic vote, right? How do you tell democracy from populism? There's no difference. There's no descriptive difference. It doesn't exist. Like, all democracy is a form of populism. Yeah, popular, right? Right. Well, if you want democracy to work on something other than popularity, then you're going to have to come up with something else and call it a new word, because no. And brigading's the same thing. Like, oh, there's so many people brigading. It's like, you mean sharing their opinion because you're wrong and you're unhappy that your tribe is smaller than you thought, or that your opinion is less popular than you thought. Oh, or that your opinion is not accounting for something, and a bunch of people are trying to tell you something that, to be fair, you probably can't see. If you've never been a release engineer on a large project, you don't know why single source matters. You don't know. I mean, even Primeagen didn't seem to know, and like, fair enough. He's probably never done that work. Let's say he hasn't worked on a big project. Have you been the guy in the back that makes all the dependencies work and fixes all the API problems by himself? Because in the not so old days, we did that. Like, I've done that. I'm not even going to say it's no fun, because actually it kind of is. If you want to learn coding, be a release engineer, not a software engineer. Oh my God. You'll see so much code and you'll have to fix so many weird things that you'll be like, oh, I see how this works. And you'll learn a lot. Now, I don't know how many real release engineering jobs there are left in the world, but boy, we need more. We need more, that's for sure. And I think if you haven't done that work, you don't know. You don't know. And that's the problem. You don't understand. These package dependency problems are because we've done away with builds. Now, I'm not saying that's bad. Like, I like Python. Like, I don't want to have to compile Python. I don't like the fact that we have different Python compile stages that go on in pip. And someone's gonna yell at me for using pip. Well, look, I can't keep up with package manager of the week, bro. Like, I got to do something. And oh, by the way, you should have built this into your language. Like, yeah, from the beginning, you should have said, we're going to need a way to resolve importing code, because, Python used to advertise batteries included. I don't know if they still do. Yeah, batteries included. What does that mean? That's somebody else's code or library or framework or whatever that you're using. Fair enough. Let's fine. Let's all cooperate. That's fantastic, right? Well, we need a way to make sure that they don't conflict, and whatever. Namespace and scoping issues. These are all issues that are resolved in builds when you do a single build. So we'll just move the problem up the stack. And the other problem is the hierarchy of software. Again, I kind of touched on this, but how you write things at the scale of 1 or 2 users is different at the scale of 1 million users. And how you deal with your backend algorithms at the scale of all the files on my computer versus at the scale of 10 million streaming files a minute, it's different. That's the hierarchy of computers, of software. There's a hierarchy there. Right? You take a guy like Matt Dillon and his Dragonfly BSD project. Like, look at Matt Dillon's freaking resume. Okay, you're not going to be him. I swear he only thinks in C code or something. He wrote a C compiler for the Amiga that was better than any of the commercial compilers, and he wrote it by himself. I mean, it was better and it was faster. It produced better code. It compiled faster, and the compiled code was faster. Like, it was just better. And he ported almost all the Unix utilities to the Amiga back in the day. And I was just like, I'll never be this guy. He's awesome. I love him. I'll never be him. And Dragonfly BSD wrote his own ZFS competitor called Hammer FS. Right? And he was doing the NetBSD contribution thing for a while, and they harassed him. Of course they did. But that's back to the law of humans. Like, yeah, we have to build systems. Those systems have to gatekeep. Like, they have to. Like, without gates, everything comes rushing in, and then no one can have anything nice. You know why you can't have anything nice? Because you're trying to let everybody in. Inclusivity, you can't be inclusive in an exclusive thing. All things have exclusion principles. Otherwise, they're not identifiable. And this all goes back to the meaning crisis. See, navigating patterns, because that's where I do more of this work. But, you just see it over and over again here in the computing industry. It's like, why are we running into these problems? These are not real problems. These are things that have been solved. Like, this is the human enterprise of civilization. Yeah, you get a group together that cooperates to do a thing. They're not going to want new people there, especially not new people who are dumb and don't know what they're talking about, but don't know that they don't know. I just did a live stream on Navigating Patterns about stupidity. You might want to see that. Stupid people don't know they're stupid. People who've never done release engineering don't know that, yeah, one single language is super useful, not just for grep, by the way, which was a valid argument. If you're saying LSP is 2016 and doesn't work for large code bases as a hierarchy of software, right? These clever little tricks that work for 100,000 line code bases are fantastic, but they don't scale. Sorry. And there's technical mathematical reasons why you should be able to figure this out, by the way. And if you can't, fair enough. Most people can't. Also, you're not the brainiac you think you are, because it is easy to figure out mathematically. Oh, LSP wouldn't work on a code base that big. Of course not. Of course not. There's math involved. There's problems that are created, right? Tracking a code base, there's a general rule of thumb, right? There's tracking something requires 4 times more data than just interfacing with it directly, right? So you wanted to track changes on a file system, you're going to end up with 4 times more data than is in the file system in a very short order. It's not instant or anything. It's in very short order, right? So it's the same with something like LSP, which was invented in 2016. Everyone was saying the 90s. It's like, no. Large code bases are hard. I mean, this is the struggle of AI. Can't deal with large code bases, although DeepSeek 3 is doing pretty good in Cursor, I gotta say. It's doing all right. It's doing all right. All right, that's token size. Oh, there's limits to token sizes. Yeah, there are. Right. Oh, we don't want different compiles in the same release, right? No, you really don't. Like, at an application level, you probably do. I've said this before. You're writing a relatively small application. Use multiple programming languages. There's no reason to program the GUI in the same language you program the backend. That's kind of dumb, actually. I've said for years. Any software project of any reasonable size that doesn't use multiple programming languages is probably wrong. Now, there are exceptions to this. The Linux kernel is an excellent exception to this. And Primeagen laid it out nicely, too. He said, look, these guys are used to having people come to the project and leave. And then if they do that, and that code's not maintainable, because this has happened in Linux kernel many, many times, then it's not clear that somebody else can just step into that role. And that's why inclusivity doesn't work, because not everybody can do every job. Do you know how to sail? Can you cut trees down with your chainsaw? Can you fix cars? Well, it's the same in programming, except there's probably more delineations in programming, right? Some people know how to do release. The thing I'm really good at is bugs and architecture work. What I'm not good at is sitting down and just starting a project from scratch. Because I'm like, well, I get into the efficiency thing. Like, oh, well, it would be more efficient to, and I could do the data structures this way or this way or this way or this way. And then, but that's really impacted, right? And then I get into this discussion with myself. And then 3 months later, it hasn't resolved because these things are impossible to resolve. And I haven't started a line of code because I don't know how I want my architecture to go. And I always architect first, which is why I don't like coding interviews, because that's backwards. And if you code that way, you're not a good software engineer, and you never will be. Right? First, you have to learn how to architect your code. And then once you've done that, once you've done real software architecture and understood the same problem solved different ways in the same or even different programming language, hopefully also in the same programming language, you really don't know anything about how to code at all. And even that won't be sufficient because, again, the law of humans, well, you still have to learn how to interface with other humans unless you're going to build it yourself. Maybe you're Matt Dillon or you're Marcus Friend or one of these other crazy people that can do that. I'm not for large projects. I've built plenty of small projects myself, but DevOps tooling and things like that. I've written Jenkins like at least 6 times before Jenkins was the thing. I wrote all of CloudWatch myself in Python and whatever. This was not hard for me back then, but I was already a pretty seasoned programmer, by that point. And that's the thing, like, that's not something you can pick up overnight. It takes years, right? You're in for 5 years. Maybe you're starting to begin to know how much you don't know. You're in for 10 years, actually doing it every day. Now we're talking, right? Anything less than that, and you just have no idea what you're talking about. Like, you don't know what you don't know. And that's part of the problem. And these people who want control of or maintenance for things with other people are parasites. Like, earn your way in. One of the stories that Matt Dillon tells is, like, he was doing some of the work on I think it was the NetBSD kernel, if I remember correctly, on the memory management system. And the guy, like I said, he's super brilliant. So he was making so many commits that because they have a very closed ecosystem, apparently, like, man, you can't commit without, like, they will not give you commit keys. But he's making so many commits that the guy who ran it finally, like, just gave him commit keys. He's like, yeah, your code's all good. It's fine. And he rewrote the entire an entire portion of the memory management subsystem for NetBSD and improved the performance. And these things are non-trivial, though, because I know how to write a memory allocator, maybe for a specific instance, but and back in the old days, people brought their own memory allocators with them. malloc was not a standard thing, or people were like, oh, malloc's too slow, because that was a big deal. The GNU malloc, and I think maybe it wasn't called malloc even, I don't remember, but the GNU memory allocator was super fast, super duper fast. The company I was working for at the time, they wouldn't touch it because of the licensing. They were just afraid. Wouldn't have been a big deal, but they were afraid. And fair enough, they're a corporation, you shouldn't take chances. But like, all the programmers I knew had multiple memory allocators in their little toolbox libraries that they wrote. And they'd share it with you and stuff, but whatever. But like, they'd pull out that memory allocator when it was needed. And that's what gave them memory safety. Like, it's not that hard. You could solve this problem in C if you were a better C programmer. I'm just saying, you don't need to build a whole new language. You might want to build, Rust is fine. Use Rust for your applications. Rust is never going to be faster than C for a kernel ever, because of the language features. It's too high level a language to write a fast kernel in. Now, it might be fast enough, and maybe no one cares, and that might be fine too, and they should do that. Like, go, please do that. Please make the world a better place with your awesome Rust kernel. I don't care. I'll use it if I have it use for it. Right? Don't steal other people's stuff. That's parasitic. Like, build your own thing. That's all. If you're that good, build your own thing. Find out for yourself. Oh, this sucks. And one of the things Hector was complaining about was all the backstabbing. I'm like, welcome to the law of humans. Are you getting around that? Not unless you're going to live someplace with no people. In which case, why are you doing your project? No one's going to use it because there are no people, right? It's just, sorry, life has trade-offs. I talk about trade-offs on navigating patterns. So maybe you want to see that there. look, I just thought I'd get a few thoughts out because this is still rolling, and I thought Primeagen's video is really good. Actually, it's the well, he's got a provocative misquote from Linus on the thumbnail, but the title is maybe the problem is you, right? And it is. I mean, maybe I'll watch the whole thing someday. I watched the first like 15 minutes, and I do really like him, but I have other things to do. I really wanted to do this video. So look, I hope you found it interesting. Let me know if the sound is fixed, in which case I will puzzle at how they broke audio on Windows 11. Yeah. And look, just software is complex. If you haven't done all these things, and I mean, I haven't done all of it, right? But I've done a hell of a lot of it. You don't understand how complex it is. You don't understand what you're talking about. Kernels are hard. That's why there aren't a zillion of them. We have too many for sure, but they're super hard. They're easy to break. And if you haven't written one from scratch or used a book or whatever, then it's a problem, right? I have Micro COS by Labrasi, and that's got bugs in it too. So it's a good book. If you don't type in your source code, I don't know. I don't think you're ever going to learn anything. That's just me. That's how I learned. But those days are gone. I get that. But also your fancy new programming language can't do kernels because it's a fancy new programming language and it has features in it that will make it slow and actually hinder the speed. And you could try it out for yourself and find out that that's true. Go write a little kernel. Go rewrite Micro COS from Labras or Minix. Minix source code's free in Rust and see if it's faster. Because I already know the answer because it's a math problem. And I checked with another math person, or a math person, because I'm not a math person. And he was like, well, yeah, certainly not. And I was like, yeah, well, fair enough. It is what it is. But just because you don't know or you think it should be that way, oh, man, I don't know. These things are hard. Building a kernel is hard. I didn't do one. I don't think I'll ever write a kernel. I should pick up Micro COS again. It's over there on the bookshelf. Maybe I'll grab it and like see how well it runs on modern hardware. Put it in a VM. We didn't have VMs back then. We didn't have what's that stupid thing called? We didn't have any of the containerization systems. Well, I can't remember the name of the basic container now. Anyway, we didn't have any of that stuff. So we had to like build a new machine and run it on the hardware. It was all kinds of fun. And that's a super simple kernel. It's kind of crappy actually. Or look at bare metal OS or something, go try to build these things in your crappy language and see how it goes. Like, it is different tools for different purposes. C is great. And it's hard to be good in C. It's really hard. Really, really hard. I'm not great in C. I mean, I can code in C pretty quick. But big memory projects, when I tried to write my own mail reader, it didn't go well. That's all I have to say about that. But then look, there's ways around it, right? You spend the time, you build a library, your C code's awesome. It just takes years, and nobody wants to wait years because they solved the video game in 48 hours. That might be a problem.